Hello, good morning, good afternoon, good evening, all. Welcome back to Swaroop IT Learning Solutions. Now, in this particular video series, we will continue to learn installing, configuring, and managing VMware Hypervisor version 8 infrastructure. So, we have already covered the following topics for providing internet connectivity to VMware vSphere Windows 11 nested VM. So, the topics we have already covered are through ESXi vCenter Virtual Distribution Switch Port Group GUI option for providing the Windows 11CL nested VM internet connectivity. That topic we have covered, and in the second part of that video we have already covered the same option through ESXi vCenter Virtual Distribution Switch Port Group option, but through Power CLI. So both the options we have covered. One option is through GUI mode, means opening those MMCs and clicking the appropriate options, and second is through command line through your Power CLI. So both modules we have covered in the previous videos. If you want to see it, you can see through my channel in the previous module numbers. Now the upcoming module is for giving the same objective, means connecting your Windows 11 CL nested VM to internet through Windows proxy and RRAS plus NAT GUI option. So that option we will cover, same objective but through Windows proxy and RRAS plus NAT GUI option. So let's start. First we will cover some theoretical concepts and then we will go for the practical mode. So in this particular video we will learn following topics. First, introduction to the RRAS plus NAT feature. What is RRAS and NAT? Then advantages and disadvantages of RRAS and NAT feature. Then advantages of using a dedicated Windows Server proxy over DC based ICS or NAT option. Then common use case scenarios. And the last one is a practical mode, providing internet connectivity to Windows 11 CL nested VM through RRAS plus NAT via GUI option. Okay, so the first A, B, C, D are theoretical concepts which I will just cover in a while, and the last option is real practical steps, around 25 to 30 practical steps through which we will configure our RRAS plus NAT and will be giving the internet connectivity to our Windows 11 nested VM. Okay, so let's start the module again. So the first theoretical concept is what is RRAS or NAT and how it works. So routing and remote access service, RRAS, with network address translation, NAT, is a Windows Server feature that lets one machine act as a gateway between two or more networks. Okay, so suppose I am having an internal network which is not having any direct ISP or public IP, but I can still give that particular VM or that system internet connectivity using RRAS and NAT feature. So it works by translating private IP addresses. So example given are 10.1.1.x, means whatever range, from an internal network into the single public or external IP address, e.g. 192.168.1.x, that will be our internet gateway of its outbound interface. It is actually translating internal traffic to external one using the NAT feature, as simple as that. So all outgoing traffic is rewritten to appear from that external IP, and RRAS keeps a session table to ensure return packets are routed back to the correct internal host. Okay, so outgoing traffic, it will use your external IP, and the incoming traffic, it will again retranslate it to the correct internal host traffic. Okay, so what are the advantages and disadvantages of RRAS and NAT feature? So here is a table. First we will see the pros and then we will see the cons. So pros will be easy to configure within Windows Server, no external appliance required. So it is a built-in feature, RRAS and NAT. So we don't require any extra application or extra external appliance. Then it provides a full stateful NAT routing and can handle multiple subnets, right? So I can have a multiple subnets of internal IPs which can be handled by using a single NAT feature. Then works seamlessly with domain joined systems and static routes. So even if your machine is domain joined and it is internally connected to your DC, that's what our Windows 11 CL is, still it will get the internet connectivity without configuring any extra IP. So through your internal DC IP only, it will get the internet connectivity also. And then the last one is it is persistent configuration, survives reboots unlike simple ICS. So in the ICS, if you are rebooting that particular system, that internet connection sharing may get reset. But in the NAT or RRAS, even after the multiple reboots, it will stay. It will be a static configuration. Now those are the advantages. Now what are some of the disadvantages? So it adds extra CPU load on proxy server with routing high volumes of traffic. So of course it needs to handle incoming and outgoing internet traffic. So it might take some performance level for the proxy server to adjust. Next is limited firewall inspection features compared to enterprise edge devices. So even if you are having internet connectivity, you need to configure your extra firewall rules. You need to configure some extra devices to act as a firewall. Otherwise, if the internet connectivity is whole open, it might be a vulnerability kind of an option for this, because RRAS and NAT itself is not monitoring any particular internet rule. It will just give you internet connectivity all open. Then it can break if Windows updates resets routing policies. So if I have updated my proxy server with some extra monthly updates which can block my RRAS policies or RRAS ports, suppose say, so it can break according to that particular scenario, and it is not ideal for the large scale or high throughput environments. If you are having a small environment, only less than 10 or 20 machines, it can work, but for the large scale it is not recommended option. Okay, so those are the advantages and disadvantages of your RRAS and NAT. So next topic is what are the advantages of using a dedicated proxy server system over domain controller based ICS. Okay, so I can give the internet connectivity to domain controller also, and through that I can share the internet connectivity through the clients which are connected to domain, but it is not a recommended procedure. So what are the advantages of dedicated proxy server over domain controller ICS? So role isolation, so keeps internet routing separate from domain authentication and DNS and group policy functions. So this means if your domain controller is already working as an internal DNS, and then once you are giving the internet connectivity also, so that internet DNS will also come into picture, that may create a conflict. So role isolation is always recommended. Next is security. The domain controller or the DC remains fully internal, never exposed to the external, that means public network. So it is recommended that your domain controller should not be exposed to internet for security reason. Next is reliability. So reboots or NAT configuration changes on proxy don't affect AD or DNS operations. So A dedicated proxy server is a whole different server, although it can be joined to domain, but it is still a separate system which is actually handling your internet traffic. So your internal AD and DNS operations will not get hampered with your internet proxy operations. Next is flexibility. So you can test or replace NAT or firewall configuration without disturbing your AD environment. Of course, as I said, it's a whole separate machine, so you can test your NAT and firewall configuration, you can reset it, you can add some extra subnets later on, whichever is required, without disturbing your existing AD environment. So those are the advantages of having a dedicated proxy server. And the last one is, of course, scalability. So the proxy VM can later host advanced services like DHCP relay, firewalling, or proxy caching. So you can add extra features also to your proxy VM without again disturbing your existing AD connectivity. So moving on to the next slide. So as we have created a diagram for our previous modules also, for this module also I have created one diagram which will make you guys understand the RRAS and NAT connectivity in more detail. So the first part of this particular diagram is the same one as we have seen in the previous model. Here is my internet connectivity, and it is connected to my ISP router, which is having a local IP of 192.168.1.1. Now my ISP router is working as a internet gateway plus DHCP server. That means it is distributing the DHCP local DHCP range IPs to my physical machine. So it is passing on that internet connectivity to my physical NIC of my physical machine plus the local DHCP IP 192.168.1.34. Okay, so this is my physical machine having internet connectivity, but with the local DHCP IP which has been provided by my ISP router. ISP router itself is having its local IP .1.1, right? So it is actually working as a NAT only. It is getting your internet IP and it is converting that internet traffic into local traffic and then distributing it to my physical machine. So up to this part we may be clear. Once this physical machine is having internet connectivity, we have installed VMware Workstation application on top of my Windows 2022 OS of this machine, and through VMware Workstation we have created 1, 2, 3 VMs that we already know in the previous modules, that is CH06, 02 and DC. Now in this particular module we'll be creating one extra VM, the fourth VM, which will act as a proxy. The fourth VM will be having a Windows 2022 operating system, and it will be having hostname Windows 2022 proxy, and then it will be having two IPs. One IP is existing 10.1.1.150 range, that means existing DC range, and the second IP it will have IP from the ISP router, that is 192.168.1.52. Okay, so it will have two NICs. One NIC is your virtual NIC which is connected to your DC. Second NIC will be another virtual VM0 which is actually connected, you can see the green line over, which is connected to my physical NIC. So the second adapter VM0 will have a actual internet connectivity. So how to add that VM0 and all we will see in the practical, but you must have seen in the previous modules also. Okay, so this VM0 is actually an important one over here, which is actually giving internet connectivity to my Windows 2022 proxy VM, and that internet connectivity is further been transferred using RRAS and NAT to my Windows 11CL. Okay, so ISP router, physical NIC, physical network connectivity, then it is passed on to my virtual network VM0, and then to my proxy, that is virtual network connectivity, and the third layer will be your RRAS and NAT, so that same internet connectivity will be passed on to my Windows 11CL nested VM, right? So the connectivity goes like this. Again, I'm just explaining: internet, then ISP router, and then physical NIC. Physical NIC to my virtual NIC, virtual bridge adapter VM0. Then through that VM0, it is going to my proxy, Windows 2000 proxy, and through that Windows 2022 proxy, it is passed on to my Windows 11 CL. Now the point over here to take a note that it is using my existing DC connectivity. You can see the color coding over here. It is the same one for 3 different bars. Okay, so you can see over here this same color coding DC plus RRAS plus NAT connectivity. That means it is using our existing DC connectivity for internet NAT purpose also. So that means I don't have to give any extra IP to my Windows 11 CL. I just have to change 2 parameters over here in network configuration of Windows 11 CL. I have to give default gateway as my proxy server's IP, local IP 10.11.151. You can see over here, and the DNS I need to give the public DNS whichever are having with the ISP router, so that it will translate the internet traffic or connectivity or the website's host resolution. Okay, so this way we are giving the RRAS and NAT connectivity to our Windows 11 CL. What are the advantages? I have already explained. It is a simple setup. No need to configure all your ESX host, virtual switch, port groups and all these things. No need to give internet connectivity to my ESX host. No need to give the internet connectivity to even to my domain controller. Okay, so everything is separated. Only internet connectivity through my proxy to Windows 11 CL. That's it. Okay, so it will be a separated and a simple setup for this. So this way we are giving the same RRAS and NAT connectivity in the further practical steps which I will be covering in the next module.